This topic is about identifying a geometric sequence and being able to use the formula for the nth term of a geometric sequence to solve problems. So what is a geometric sequence first? It goes from one term to the next by multiplying or dividing by the same number, which we call the common ratio. So when we multiply, we call it the common ratio. So if A is equal to the first term, R is equal to the common ratio, N is equal to the number of terms, then the sequence is A, which is the first term. We times by R, which is the common ratio, to get AR. We times by R again to get AR squared. Times by R again to get AR cubed. So this is U1. Let's see what the nth term would be. So all the way up to times by R to get the nth term. What would the nth term be? This is U1, this is U2, this is U3, this is U4, then UN. If you look at it, you always have an A, and then R raised to 1 less power, so n minus 1. Therefore, UN is equal to AR to the power of n minus 1. And the other way of defining it, which is the recurrence relation, is UN plus 1 is equal to R times UN, where U1 is equal to A. So the two ways of defining this geometric sequence. Okay, let's go through some examples now. Find the 14th term of the following geometric sequence: 3, 12, 48, 192. So I can see I'm multiplying by 4 to get the next term. So in this sequence, A is equal to 3. The common ratio is 4. N is equal to 14 because we're trying to find the 14th term. Then UN, the formula we're using is UN is equal to AR to the power of n minus 1. So U14 will be equal to 3 times 4 to the power of 14, take away 1, which is 3 times 4 to the power of 13. We put this into the calculator, we get 201,326,592. A geometric sequence has third term equal to 18, so U3 is equal to 18, and sixth term, which is U6, is equal to minus 60.75. U3 is, because UN is equal to AR to the power of n minus 1, U3 will be equal to AR squared is equal to 18. And we've got U6 is equal to minus 60.75, so AR to the power of 5 will be equal to minus 60.75. So we call this equation 1, and we call this equation 2. Then if we do 2 divide by 1, we'll eliminate A. So AR to the power of 5 divided by AR squared will be equal to minus 60.75 divided by 18. So you know the A's and the A's will cancel out, the R squared will cancel out with the R squared on top, so we're left with R cubed on top. So that means R cubed will be equal to minus 27 over 8, which means R will be equal to cube root of minus 27 over 8, which is equal to, which implies R is equal to minus 3 over 2. Okay, so we found the common ratio. If I want to find the first term now, substitute R is equal to minus 3 over 2 into AR squared is equal to 18, which implies a times minus 3 over 2 squared is equal to 18, which implies a times 9 over 4 is equal to 18. So if I do a is equal to 18 divided by 9 over 4, then end up getting 8, which means therefore a is equal to 8. Okay, the numbers 5x plus 1, 4x minus 4, and 3x minus 5 form 3 consecutive terms of a geometric sequence. So this is u1, u2, and u3. And to get from one to the other, because it's a geometric sequence, you are timesing by r. So that means if I do u2 over u1, I get r. And if I do u3 over u2, I also get r, which implies u2 over u1 is equal to u3 over u2. So that means 4x take away 4 over 5x plus 1 is equal to 3x minus 5 over 4x minus 4. So let's cross multiply. So if I do 4x minus 4 times 4x minus 4, it will be equal to 3x minus 5 times 5x plus 1. Okay, if I expand the bracket, I get 16x squared minus 32x plus 16 on the left-hand side. On the right-hand side, I get 15x squared minus 22x take away 5. If I move everything to the left-hand side, I get x squared minus 10x plus 21 is equal to 0. When I factorize it, I get x minus 3, x minus 7 is equal to 0, which means x is equal to 3 or x is equal to 7. Part 2. Find the common ratio corresponding to each possible value of x. So if x is equal to 3, implies r will be equal to 4x minus 4 over 5x plus 1, which is the same thing if I substitute x equal to 3. It's 4 times 3 take away 4 over 5 times 3 plus 1, which is equal to 8 over 16, which is equal to a half. So that's one answer. So which implies we've got x is equal to 3 and r is equal to a half. That's one answer. And the second answer is if x is equal to 7. If x is equal to 7, it implies r, which is equal to 4x take away 4 over 5x plus 1, will be equal to 4 times 7 take away 4 over 5 times 7 plus 1, which is equal to 24 over 36, which is equal to 2 over 3. So the other solution is x is equal to 7 and r is equal to 2 over 3. The value of gold in 2000 was £180. The value of the gold increases by 5% per annum. Okay, A, write down an expression for the value of the coin after n years. So that means 180 is at the beginning. To get the next one is 180 times by, if you increase by 105 by 5%, you get 105%, which is equal to 1.05. So 1.05 is the multiplier. So it'll be 1.05 to the power of 1. For the next one, it'll be 180 times 1.05 to the power of 2 after 2 years. 180 times 1.05 to the power of 3 after 3 years, which means for A, un is equal to 180 times 1.05 to the power of n. Okay, because obviously the first year is the 0th year, so it's not after 1 year. This one is after 1 year, so this one is after 1 year. That one's after 2 years. After 1 year, after 2 years, so on. Okay, B. Find the year in which the value of the coin exceeds £360. So that means UN is greater than £360. Which means, because we already know what UN is, 180 times 1.05 to the power of n is greater than 360. If I divide by 180, both sides, I get 1.05 to the power of n is greater than 2. If I take logs on both sides, I get a log of 1.05 to the power of n is greater than log of 2, which means n log of 1.05 is greater than n log 2, which means n is greater than log 2 over log 1.05. Which means n is, if I put that into my calculator, L is greater than 14.2. So that means after 14.2 years, the value of gold will increase. So after 14.2 years, the value of the coin exceeds £360. So after 14.2 years, therefore this is during 2014. A car depreciates in value by 15%. If it depreciates 100% takeaway, 100% takeaway 15% is equal to 85%. So the multiplier is 0.85. If it is worth 11,054.25 after 3 years, what was its new price and when will it first be worth less than 5,000? So if the original price is A, after 1 year it will be A times R, after 2 years it will be A times R squared, and after 3 years it will be A times R cubed. So this is price after 3 years. So that means AR cubed is equal to 11,054.25. But A we know, so R, the common ratio R, since R is equal to 0.85, that means A times 0.85 to the power of 3 is equal to 11,054.25. So A will be equal to 11,054.25 divided by 0.85 cubed, which gives us a value of 18,000. So it'll be £18,000. So if I want to write pound signs everywhere, I'll see it. When will it first be worth less than 5,000? So if I think about it, AR to the power of n is the price after n years. So that means AR to the power of n, when is it less than? So when is it less than 5,000? So that means A, we worked out already, it's 18,000 times R, which is 0.85 to the power of n. When is it less than 5,000? So first thing we need to do is divide by 18,000 both sides. 5,000 divided by 18,000 is just 5 over 18. Now we need to take logs on both sides. Log of 0.85 n to the power of n and log of 5 over 18. Just going to go here. So n log of 0.85 must be less than log of 5 over 18. Now we need to divide both sides by log of 0.85. Now log of 0.85, obviously 0.85 is a number between 0 and 1, so you're dividing by a negative number, so it flips over. So n must be greater than or equal to log 5 over 18 over log 0.85, as log 0.85 is less than 0. If you put this into a calculator, n is greater than 7.88, which means n is equal to 8. Therefore, it will be worth less than £5,000 after 8 years. Find which term in the progression 3, 12, 48 is the first to exceed 1 million. So that means we times by 4. So A is equal to 3 and R is equal to 4. So when is UN greater than 1 million? So when is 3 times 4 to the power of n minus 1? Okay, let me just write the formula. So when is AR to the power of n minus 1 greater than 1 million? So when is 3 times 4 to the power of n minus 1 greater than 1 million? So first thing we need to do is divide by 3. So 1 million divided by 3, which means 4 to the power of n minus 1 is greater than 333,333.3 recurring. Okay, you need to take logs on both sides. So log of 4 to the power of n minus 1 is greater than log of 333,333.33 recurring. That means n minus 1 log of 4 is greater than log of 333.33 recurring, which means n minus 1 must be greater than log of 333,333.33 over log of 4, which means n minus 1 is greater than 9.1733, which means n is greater than, if you add 1 to it, is 10.1733, which means n must be equal to 11. A virus is spreading such that the number of people infected increases by 4% a day. This increases by 4% a day. The multiplier is 1.04. So the common ratio is 1.04. Initially, 100 people are diagnosed. So A is equal to 100. R is equal to 1.04. We just figured that out. We're diagnosed with the virus. How many days will it be before 1,000 are infected? So that means initially is 100. After 1 day, it will be 100 times 1.04. After 2 days, it will be 100 times 1.04 squared. So that means after n days, it will be 100 times 1.04 to the power of n. So what we need to do is, how many days will it be before 1,000 are infected? It means the nth term, which is 100, nth day, which is 100 times 1.04 to the power of n. When is it equal to 1,000? So I need to divide by 100 first, both sides. So I get 1.04 to the power of n is equal to 1,000 divided by 100, which is 10. If I take logs on both sides, then log of 1.04 to the power of n is equal to log of 10. So n log of 1.04 is equal to log of 10. So n will be equal to log of 10 divided by log of 1.04, which means n is equal to 58.70839. If I round it, because it happens after 58.7 days, it must be n is equal to 59. I invest £8 in the bank at a rate of interest of 3.5% per annum. So that means A is equal to capital A. How long will it be before I double my money? So if A is equal to A, my common ratio, because it's increasing by 3.5%, my multiplier is 1.035. So that means my first term will be A, my second term will be A times 1.035 after 1 year. After 2 years, it will be 1.035 to the power of 2. All the way up to the nth term will be A times nth year, sorry, at the end of n year will be 1.035 to the power of n. So I want this after n years to be equal to double my money double my money is equal to 2a. So a times 1.035 to the power of n must be equal to 2a. That's the equation I'm trying to solve. So if I divide by a, I get 1.035 to the power of n is equal to 2. If I take logs, log of 1.035 to the power of n is equal to log of 2, which means n log of 1.035 is equal to log of 2. If I divide by log 1.035, I get log 2 divided by log of 1.035, which means n is equal to 20.14879, which means n must be equal to, because it doesn't say it's paid at the end of the year, it just says it's paid, it must be 20.15 years. The fish in a particular area of the North Sea are being reduced by 6% each year. If it's reduced by 6%, my common ratio is 0.94. So A is equal to A. So we don't know what the first term is. Reduced by 6% each year due to overfishing. How long will it be before the fish stocks are halved? So A is equal to A. We don't know what it is. My common ratio is 0.94. So that means my first term is A. My second term will be A times 0.94. So after 1 year, 0.94. After 2 years, it will be 8 times 0.94 to the power of 2. All the way up to after n years, it will be A times 0.94 to the power of n. So we need that equal to half the stock from the beginning. So it's equal to half A. So the equation I'm trying to solve is A times 0.94 to the power of n is equal to half A. If I divide both sides by A, I end up getting 0.94 to the power of n is equal to a half. If I take logs on both sides, I get log of 0.94 to the power of n is equal to log of half, which means n log of 0.94 is equal to log of half. If you want to write 0.5, you can do that. So n is equal to log of 0.5 over log of 0.94, which is log n is equal to 11.2023, blah, blah, blah. So n is equal to 11.20. It was measured in years, so 11.20 years. Okay, the last as a summary. So if a sequence 1 is 4, 4r, 4r squared, 4r cubed, and the sequence 1 is increasing, what can you say about the value of r? If it's increasing, it means the numbers are getting bigger, which means r cannot be less than 1, so r has to be greater than 1. Sequence 2, 100, 100 times t, 100 times t squared, 100 times t cubed. Sequence 2 is decreasing, so it's going down. What can you say about the value of t? Obviously, t can't be greater than 1, so we can eliminate that straight away. T can't always also be negative, because if it was negative, it's going to alternate from positive to negative to positive to negative. So it can't be t is negative, which means t must be between 0 and 1, because that would mean as we're multiplying by t, the number is getting smaller because the number is between 0 and 1. So the effect t has is makes the value smaller. Sequence 3, 15, 15 times s, 15 times s squared, 15 times s cubed. Sequence 3 is neither increasing or decreasing. What can you say about the value of s? If s is equal to 1, then obviously you're going to get 15, 15, 15, 15, which is neither increasing or decreasing, so that works out. Also, if s is less than 0, which is negative, then it's going to be the value is going to be positive, negative, which is neither increase or decreasing. So you have two different cases for this one. Either s is equal to 1 or s is less than 0. The last sequence, a times r squared, a times r cubed, a times r to the power 4. Sequence 4 is increasing. What can you say about the value of a and r? Okay, you have two cases. So first case is when a is greater than 0, and second case is when a is less than 0. Now, if a is greater than 0, we also need r to be also positive, but also increasing. So that means r must be greater than 1. It can't be less than 1 because then the number would be decreasing. So each value would be decreasing. So r has to be greater than 1. If a is less than 0, then we can't have r is negative. R has to be between 0 and 1. Because if r is between 0 and 1, then you've got negative numbers everywhere because of a being negative. But because r is between 0 and 1, it's going to multiply a number by a number between 0 and 1, which is going to make it increase as we go along.